Welcome to Beyond Blueprints. I'm Andrew Smith, and today we're delighted to be joined by Shiladitya Ghosh, or Shil, who is the COO and co founder of Mission Zero Technologies. Thanks so much for joining us today on Beyond Blueprints, Shil. And to start off with, I wanted to ask you, what is Mission Zero Technologies all about? What problem is it solving?
Thanks, Andrew. Great to be here, and thank you for having me on this podcast series. It's really great to be here speaking about Mission Zero. What we're here to do really is to develop a form of climate technology that focuses on removing CO2 from the atmosphere around us, something that global experts, scientists, and the public all agree on is that man made impacts of climate change through CO2 emissions through industrial activities has reached a point where it has become unsustainable and we need to reduce that level in the atmosphere. Otherwise, we're going to be facing catastrophic effects of climate change globally. So, one of the ways to do that for future and current emissions are, of course, through the energy transition, through moving to renewables and other decarbonization approaches. But those approaches don't offer us ways to fix the CO2 emissions we've made in the past before we realized this was a problem through the last 100 years of industrial activity. One of the ways we can tackle those past emissions are through atmospheric carbon removal technologies like what Mission Zero is building. We are literally cleaning up the mistakes of our past through a technology that removes CO2 from where it was produced into. This is quite difficult to do because the concentration of CO2, somewhat surprisingly, is quite low in the atmosphere around us. It's only 400 parts per million, which at once is more than it should be, but also really low to make it easy to remove. And which is why this wasn't something that people knew how to do before. But nowadays, companies like Mission Zero are taking on this challenge to make sure that we have a pathway to sorting this out.
Okay, I mean it's fascinating technology to me, and excuse my ignorance, but in simple terms, how does a DAC system work? How does direct air capture work? How do you manage to get such a small proportion of carbon dioxide out of the air?
Yeah, so when we realize that such a small percentage of the air around us is CO2, it stands to reason that to get any meaningful amount of CO2 out of it, we need to play around with huge volumes of air. There's no getting away from that fact. And luckily, we have technologies out there that are really good at moving huge volumes of air around. So, unsurprisingly, the first step in any carbon removal technology is air circulation through technologies such as cooling towers, which are used in industry very commonly in huge volumes to move huge volumes of air to cool down processed liquids or other streams or materials. And the very similar infrastructure can be used for the first step. This is often used in two different ways. There are two flavors of how this technology is deployed in direct air capture. One is to bring that air in contact with a solid capture material called a sorbent. So this could be a synthesized structured material with high surface area and a active capture chemical on the surface of it. So when the CO2 laden air passes through it, the CO2 gets in contact with that material, reacts with it, and is removed while the rest of the air flows out. The other approach is to employ a liquid system, which is what Mission Zero preferred to use. So, a liquid system is just like imagining the ocean. When you have air flowing over the ocean, you have water that evaporates, and you have other things that go into the ocean, for example, contaminants and pollution. And in a similar way, in a cooling tower with a liquid system, when your airstream goes over a liquid capture solvent, the capture species targets the CO2 at the boundary of the two materials, and the CO2 goes into the liquid, leaving the rest of the airstream free to go out.
Okay, so the knack is you're not grabbing it direct; you go via an intermediary, and then you're able to release it. That's the kind of the knack to making DAC work.
In a way, from an infrastructure and footprint perspective, certainly that is where most of the uh, land area or capex size is devoted to for data capture technology. For example, any DAC facility or plant that you might see visuals or renders of in the media, most of that footprint is the capture process, the contacting process of the air and the capture system because of that volume requirement. However, that is not actually where the costs and the innovations are primarily focused on. That is in the second stage of the process, which I'm happily going to touch on once you're ready for that.
Okay, perfect. So let's talk a little bit before we get onto that. Let's talk a little bit more about Mission Zero itself. So you were founded in 2020, so sort of mid-pandemic, but be making a bit of a buzz. I saw that you were the only UK company to be awarded an initial $1 million X Prize, which is a carbon removal competition. I mean, how did that feel? Because that was within kind of 2 years of your founding. That must have been a real boost to have such a claim.
Yeah, it was definitely a momentous occasion for our very young company at that stage, probably our biggest milestone till date. And it, of course, felt amazing to be recognized that way, but it also really drove home the responsibility and mandate that we have, even as a young company, that this global engineering and science and innovation competition with entrant like over 1,100 teams taking part,
Wow.
we as a 2-year-old company are one of the 15 most promising technologies identified by experts to potentially save the world, to exaggerate a little bit. So there's a little bit of pressure that comes with that, but a lot of motivation that also comes with it, that okay, we have such an excellent opportunity to take this momentum, bring it forward, and never look back. There is no one ahead of us, or almost no one ahead of us in this space. All of the innovation, all of the success, all of the proliferation of this technology can and should be led by companies like us. And having that mandate, having that recognition from a prize and competition like the X Prize that you just described, and also through some of the fundraising that we've done through investors externally, has really just brought home that message. And it's not a scene that we alone feel that we're going to solve the problem. We are only one of 15 winners. There are 14 other winners and probably countless others who are deserving, which is just great news for the planet because no one knows truly how many of these technologies are going to succeed and how well they will perform if they scale up. So we need all of these technologies to have the best shot they can have in making sure that at least one or two of them work out. So we're glad to be part of that equation as long as possible.
Amazing. You talked a little bit about kind of you're feeling a bit of pressure because it's an important climate problem to solve. I read in a profile, you could tell me if you've been misquoted here, Shil, but I love the quote. It was really fascinating to me that you said, your the dream was to be so successful in healing the climate that the industry goes defunct, which I guess is quite a unique kind of position to be in as a business, that ultimately the goal is to remove it completely. I'm just interested to hear your reflections on that, it's an interesting thing to have to juggle, that what you're shooting for, ultimately the desire is not to be needed,
Yeah,
right?
it's a good point, and I definitely still stand by that sentiment, and I think my colleagues would echo that as well. However, there is a little bit of nuance to that because the way we see direct air capture technology being useful to society and industry is actually in two ways. The first is definitely from the climate impact perspective of removing historical emissions, like what I mentioned before. And that is definitely the application in which we want to thrive and succeed, so much so that there's no need for us anymore. However, that whole carbon removal function is always meant to be a temporary band aid solution while things like the energy transition and the circular economy can take hold and proliferate into our society as a long term thing. And there is room for direct air capture in that as well. Not just room, there is a scope that is uniquely enabled through direct air capture there. For example, using DAC to provide sustainable sources of carbon for a lot of product synthesis routes or fuels or other valuable materials. There's no chance that our society is going to wean itself off these material needs as we grow and progress civilization. And currently, most of those materials are manufactured using fossil derived products or feedstocks. And so, once, hopefully, in the ideal scenario, we remove the climate consideration of global warming, DAC can still be around to play a part in fulfilling those supply chains as a CO2 feedstock provider for sustainable carbon. Um, if we are worrying about how that plays out and we solve this problem, then I think we're in a great position.
That's a great answer. I love that as the destination. It feels like we're going to need it for a very long time anyway. Speaking, you touched a little bit on this that you're pretty far ahead in this space. Um, as much as you can say, what is it that sets Mission Zero apart from the competition? What's unique about your approach?
Definitely. I mean, when we started Mission Zero, there were probably around 3 or 4 DAC companies out there in 2020. Um, I think last week we heard at a conference from investors and experts in the sector that there's about 200 of them right now. So it grows ever more
Wow. Okay.
challenging for people to really comprehend what is the difference between all of these companies who are trying to do the same thing. Um, Most often, the variance is in the specific chemistry or technology architecture that one might be using over the other. Um, However, in the case of Mission Zero, what we have so far, which still stands true as being unique, is how we think about technology development and engineering activities in the company. The way that Mission Zero's IP so far has been generated, for example, is not through the usual scale-up route of, say, university R&D research or laboratory synthesis of a particular chemical or a reagent that initially is made at a test tube scale and then is proven to capture carbon under very controlled conditions, publish papers, then you get some investment that spins out. You do benchtop scaling, spend 5 years refining the material stability or the physical stability of something. Then you have some pilots. Then you go to scale, and that's 10 years. Those are the routes that really important technologies like solar PV took to commercialize and scale up. They had the time to do that. In carbon removal, no one has the time to do that. However, a lot of other technology players in this space are doing that approach, and we do wish that as many of them succeed as possible. But the way Mission Zero is thinking about innovation and R&D is actually looking at where do innovations that fulfill our specific needs already exist in other industries and applications that we can leverage for direct air capture. One way to illustrate this, for example, is famously how Nintendo approached development of their gaming hardware when the Game Boy was developed in the late 80s or early 90s. They didn't go out to build whole new architectures, sensors, circuitry, motherboards, and so on from scratch for a state of the art next generation gaming system. They went and looked out for what components exist out there that have mature supply chains that we can just cobble together and produce a simple gaming system that still reaches our objective, which is for people to be entertained and have fun. And that is the philosophy we're trying to embody here. What are the technologies or the key components, supply chains, chemicals that already are produced at the scales that the carbon removal industry is going to need that we can connect together and fine tune to make a functional and cheap and effective direct air capture technology? Because once we prove
So
that it
is
works,
that
we need to then be able to build enough of it to make a difference.
so is it innovate where it matters, but don't reinvent the wheel? If I was being
Basically,
very if I was condensing
basically
that down,
steal the wheel
is that
from
what you're saying?
another sector is what we're doing. Steal the wheel from a different type
Steal.
of vehicle is what we're going for.
Don't reinvent the wheel. Take it off the mature one that's gone down the road. Really really interesting. And can you speak at all to the what's the question I'm trying to ask? The technology aspects then. Is the technology where some of your secret sauce is, or is your secret sauce really in that how you're going to productionize quickly to get this to market?
It's at this stage, it's definitely in a bit of both. So what we've done, what I've described in looking at existing supply chains and infrastructure that we can leverage to put together technology. So then what the product that comes out of that, the secret sauce for us, is the design thinking of how a system should look, what each part of that system needs to be able to do to make a functioning and effective direct air capture system, wherein the identity of each of those components are interchangeable. For example, in our capture part of the process, we have our system designed such that any chemical system that can do X, Y, and Z things with certain numerical bounds on those is going to be a perfectly adequate material to use in a implementation for our system, which gives us a lot of flexibility because For example, if we're deploying a project in the United States, there are certain chemicals and things that are acceptable for use in certain ways. There are chemicals that are prohibited, and so we can implement one form of capture solvent in a plant in the US. If we do one in the UK, the list of prohibited and accepted chemicals are not the same. And so what we want to use there might not be suitable here, but the rest of our process is able to accommodate a change in that chemistry fundamentally. That is part of the secret sauce, but also simply the way of engineering that we have here that gives us that flexibility, which we don't see in many other DAC approaches because they start building their technologies based on a fixed chemical or physical component that is unchangeable and is intrinsic to their IP. Um,
A very small demonstrator, and then they've got the problem of scaling,
yeah,
whereas you're
and they're always
thinking
going to be
from the
tied
outset
to
about
that
how it's going to be
material
used.
X and whether they're allowed to use that, whether they can manufacture that, or things like that. Whereas we're not tied to any of that.
Okay, fascinating. Yeah. So that's a bit about Mission Zero. I want to ask Sheila a bit more about your background because you've got the quite kind of, I guess, fun path of going straight from doing a PhD in quite a niche aspect of engineering and then going straight into becoming a founder. Or I think there might have been a slight overlap there. You were a founder before you finished your PhD. Is that right?
There, that is right. There were quite a few things going on in the year before I finished my
Must have been.
PhD. Um, not least to mention the pandemic itself, which made anything anyone was doing challenging, if not completely unfeasible. But in 2020, I was writing up my thesis and had my viva. I also started and completed a part-time MBA, and I started working on Mission Zero all at the same time because there isn't enough time to do all those
You
things in
put your
sequence.
pandemic to good use.
What was that?
You put the pandemic to good use by the
That is
sounds of
true.
it.
I think it was a very thin silver lining on the cloud of that the pandemic was on all of our lives, that it gave me the time for these opportunities and forced me to do them by taking away possibilities of other things that I could have been doing at that time. So it was quite fortuitous, and I'm I'm not going to comment whether I'm grateful or thankful that things panned out that way, but I am grateful for where I am now and what impact I feel I can bring to this space and in this industry. But you are right. So there was an overlap between me finishing my PhD and beginning Mission Zero, which I think helped also from the engineering perspective because I was still fresh in the thinking and the tools and skill sets that I was using during my PhD. That was really helpful in starting to scope out a direct air capture company and analyzing different approaches, optimizing things, doing analyses, trade-off investigations, and just being in the technology mindset and research mindset to explore the space. So that was really valuable.
And was there the other thing, and this is maybe a bit of a cheeky question, excuse me, but friends who are in academia, they're always in some sort of funding cycle, or they have to go through the pain of the funding cycle. Do you think that made you battle ready for going into a startup environment where I imagine that's something you also have to contend with?
Yeah, it's true. I was lucky or unlucky, depends which way, not to be that closely involved with like funding cycles for academic R&D in university. Uh, my funding was clear from the start, so I didn't have that barrier. But I did see a lot of my peers continually have to adjust what they want to research versus what the funding said they're allowed to spend their research activities on, right? And for
Mm.
for anyone who likes technology and research and developing new ideas, innovating, being constrained is the worst feeling possible. Whereas if you're a startup entrepreneur trying to build a new technology, when you receive investment, at least in the early stages, you have all of the flexibility that you want, as long as you are still working towards the goal of whatever you pitched your technology to be doing. And we pivoted many times in our technology development journey from day one to even filing our first patent. So that flexibility, which we would probably not have faced in a university setting, was really also instrumental in us finding the best version of ourselves till date. And I'm sure there's more iterations to come as well.
And did that transition between kind of finishing up your PhD, the MBA, everything else, going into the startup full time? did that feel like less of a steep learning curve? Did that feel like more of a ramp up, or how did you find that transition?
I uh, to be candid, I felt as if I was coming into my natural environment rather than anything else. And that was because something like doing a PhD, the experience of that and how that goes for people varies wildly. Some people really thrive in that structure and environment and program. Some people don't do so well. I'm definitely on the latter. And I knew from my previous time as a student and undergraduate being involved in various activities, extracurriculars, all sorts of things, that I do really well when I am kind of almost overloaded with responsibilities and different types of activities to be doing so that my attention constantly shifts. Because when you're developing technology or you're building a startup, you are not just working on one experiment or one area of research. You
Yeah.
need to find time for an experiment. You need to find time to speak to customers, to speak to investors, speak to mentors, advisors, um, other peers who are in the startup space to get their ideas, speak to the landlord of the office room you're renting, get cleaning service, sort out the whole gamut of things, right? And that kind of chaos is where people like me actually thrive. So it felt very natural and comfortable for me to straight away jump in to working in a startup, building a startup even.
It's I'm sure that is not a unique founder trait as well. Is that you have to never have has it been put more eloquently how much of a multidisciplinarian you have to be to be a founder. I wanted to ask you, I guess, about a personal motivation. What inspired you into climate technology? Is that something you've been passionate about for a long time, or was it a right place, right time in 2020? You saw a new avenue to go down.
Yeah, I think sustainability would be the umbrella that I've been passionate about since I was probably old enough to know what that meant in middle school. Because I grew up in Singapore, which is near the tropics, but it's an island country. And so, living in an island country, you are very acutely aware of the threats that the climate can affect on you, rising sea levels, storms, all of these things. Plus, being an island country, you don't have natural resources, so you are much more vulnerable to things like this. So that made me maybe more acutely aware than I would have liked to be at the age of 8 or 9 years old about all of these problems. But that did luckily turn into a motivation that whatever I do when I grow up, I want to make an impact in sustainability. That was the first step. So in high school, I did research projects for science fairs and things like that, or my um, I did the international baccalaureate for my pre-university studies. So there was an extended essay project for chemistry where I looked at wastewater purification to remove heavy metals, because that was what seemed interesting to me and also manageable at that stage. But then when it came to applying to university in the UK, where they ask you like, okay, write your personal statement. What do you want to do? Why do you want to study course X, Y, and Z? That really made me think, okay, I've got this experience in sustainability. I understand some amount of what's happening with climate and the environment. What do I want to do? Two things that were catalytic here in shaping my interest in carbon capture specifically. One was actually seeing among universities that Imperial College, just that year, which I was applying to, had just unveiled a new state of the art carbon capture facility in my would be department, which is a multi-story point source carbon capture facility that's sponsored by ABB and a few other companies. So brand new shiny toy. If I go into this field, there's something amazing that's industry relevant that I can learn about. Plus, the second thing that was really motivating was um, maybe my kind of moral compass or value system. Growing up in a place like Singapore, even though it's a small country, it is a very affluent place with a really high quality of living. But I know that for many people, life isn't like that, especially from where my family is from, for example, in India and other parts of the world as well. And feeling the privilege of having a really good education growing up, really good quality of life, good housing, having all of my base level needs as a human being met without even having to think for it, and therefore being able to progress up made me feel kind of obliged to spend all of this resource that society has invested in me to give back in future. And one of the best ways I could see to do that was through the climate, because that is something that is everywhere and affects everybody equally, whether you're rich or poor, whether you have food, whether you have money or not, it affects you. And so that seemed like a really attractive way to make the impact as equitably as possible and as widespread as possible. So that really motivated me to focus on carbon capture specifically. I wrote about that in my personal statement. I think I probably did. If I wrote it now, I would definitely do that. And then I got into Imperial. I did my research projects in a research group focusing on carbon capture, got the taste for that, realized that, yeah, this works. I get it. I understand it. I enjoy it. I want to work in this space.
Okay, amazing. Um, Really interesting origin story, and you can see the passion coming through. It's a lot of weight to put on your shoulders, though. You talked earlier about you feel the pressure of getting this funding coming in, and then I guess you've got the you feel like you're doing it for the planet. Does that weigh heavily, or do you just find it motivating?
I find it motivating. Like, it's the difficult things that get me out of bed, not the easy things. In general, like even at university or school, like I wouldn't go out to lectures if it was a topic that I felt I understood well. I would only go to the ones where I didn't know what was going on at all. And same for like tackling challenges. I always, luckily or unluckily, there's always an abundance of really difficult problems to solve at a startup tackling a really difficult problem to solve, which is carbon removal. And so that is definitely motivating for me. It does feel like something there's always the thing that's behind me that the clock is ticking. We only have X number of years before it's too late to do anything meaningful about it. But that just gives more
Hmm.
incentive. It makes sure we are always giving at least 100% in everything we do. I don't speak just for me, but also almost everybody at the company, if not everybody at the company, feels that way. And that's just a great space to be in. We're surrounded by people who feel the same way and have the same sense of urgency.
Yeah. So you've got a shared, I guess, mission. It's in the name, right? You've got you've got a shared mission.
We have to grow up
Um,
in and survive in. So if it's not fit for purpose, it's our own problem.
yes, yeah, no, well, I completely agree. You talked about the team there, and I'll leave it to you whether you could say how order of magnitude of where the team and scale of Mission Zero is at. But I'm always interested to ask, especially as your co-founder, how you balance that agility and ability to move quickly with everybody that's working with you aiming in the same direction. Always feels like there's a bit of a balance to be struck there.
Yeah, absolutely. So firstly, we are a team of about 24 people right now, including interns. And most of our team is skewed towards science and engineering functions, maybe unsurprisingly, because that is where most of the key leverage activities at our stage of being a company needs to be at. We are
Hmm.
delivering projects over the next quarter to customers, which is super exciting. But all of that is made possible by what you just alluded to, um, making sure everyone is aligned to the goal and knows exactly how far along we are on that goal, how each person's work needs to feed into each other to make sure that everyone has joined a picture and is pulling in the right direction. And so what I alluded to at how Mission Zero started, where everyone, all of us founders are doing like the small 5 minute things, the 2 hour things, the ordering office stationery to speaking to investors and getting term sheets and all these things. That is how things start. And we do and we did needed to concretize and segregate out a little bit so that there is clearly defined scope. For example, how do we approach science R&D versus engineering? They're both technical, they're both working on our technology, but their functions are different. Engineering
Mm.
in Mission Zero is to take what we know for certain and try and make that a reality with our customers and our engineering partners and collaborators as far as possible, while our science and R&D function continue to optimize and improve and find new things we can do the next time we have to do that as an engineering function. So there's a lot of information management that is required there, a lot of change management, both directions. So both teams understand what is locked in for project X, Y, and Z, what is not locked in, and we are able to modify that. Until when can we do that? Which things seem like the most important things to explore changing until that date? Which things probably don't matter? Being on top of all of that, I'm not going to claim by any means that we have nailed the perfect solution for that. We're still working on it, but the first step in that is everyone understanding that having that clarity and communication is really important, and we have that part at least, and we're working on the rest.
everybody having everybody having the same, I guess, source of truth becomes really important as you grow, because I always think if you can look around a single table at everybody you're working with, then that's a manageable number of nodes to just push out. But once you grow beyond a certain size, yeah, you start needing to be careful. Related to that, then, as you've grown to this, team of 24, how important in the your ways of working and the tools that you're using, how important is usability in that?
It is super important because we don't want our team members to spend time figuring out how to do something in an interface or in a software or in a document. We are paying for their time, and they are here because they're really good at doing whatever it is they're trying to do, not trying to figure out how to make something happen on an interface, right? And so, for example, there's a spreadsheet which models, say, the performance of one component of our capture system, and someone wants to implement a new change to that because they've got new learnings from the R&D side. We don't need them to spend like an hour trying to figure out the right cells to change in that spreadsheet to put in information and then see if the information that results from that is useful or not. We want them to be able to do that without worrying about it and more spend time thinking about the output of that. What impact does that have? Who do I need to inform? Is this something that I should raise to someone else? Do I need to speak to a collaborator and let them know something's changed? Those are the important things that we want people to be able to spend their time on, not how do I change the Excel spreadsheet, for example, which is how
Yeah,
usually engineering
we
is probably taking place in most parts of the industry.
we've had a few interesting discussions on the podcast about Excel, the highs and lows of Excel, basically, and I'm sure it's something that every engineer can relate to. What starts off as something small soon balloons into a monster, and somebody needs to kind of chip it into shape. Um, on that question of you've said tools need to be really usable, and you've got to be all pulling in the same direction. Was that a challenge for you? Because going from being kind of the engineer to then having to think about how we actually structure a team and get people pulling together in the same way, has that been where the learning curve is from being really on top of the technical stuff?
Yeah, it's definitely part of where the learning curve is for me actually right now as we speak, as I move into company and business operations, and a big part of that is managing how people work effectively in the company, not even like what they're doing and what resources they need or what chemicals they need and all of those kinds of things, but how do they manage information? How do they communicate with each other effectively? How do they record and capture things so other people can find them? How do they know how to look for things? Because the more people come into Mission Zero, that problem becomes exponentially more challenging to solve, as with any company.
Yeah.
And that is the problem, that you do not want people to have to spend any time at all trying to figure out how to navigate. So it has been a really challenging thing, but it has been helpful for me to firstly hire in excellent people that we can trust to take over on the engineering front, so that me as a founder can step away and look at building the infrastructure that the company needs and the teams need to communicate effectively on deeply technical topics. Because as a founder, initially it's just you and your co-founders plugging away on the thing by yourself. But the whole point of hiring people in is to help you execute your vision, and you are there now to enable them to perform their best as far as possible as leaders of the company.
Yeah. Is it hard to let that go when you've been kind of there at the technical co-face to then it's great, obviously, because it's kind of growing bigger than you, but is it hard to let go of that technical immediate connection?
At this stage, it's not being so noticeable because no matter how much I try, I can't really escape it. There's always something that needs me involved at the stage
Pull,
of company we're
pulls you
at.
back in.
I can see probably in the next round of growth, I will get isolated enough from that. But I think it is a fresh experience to not have to think about it. And just knowing that I have these wonderful colleagues and people that we can trust to get that right. Knowing also that I have armed them with the tools and infrastructure to do that in the most error-free way possible. I'm not saying that I have done
Yeah.
that yet, but
Yeah,
that's what
cool.
we're working on.
Oh, it's exciting. So, we always like to ask the next question, and it's a little bit of a provocative one. But, Mission Zero today versus if Mission Zero was here in 1985, is the approach the same, or has something fundamentally changed in that time that means now is the right time for Mission Zero?
It's a good question. I wasn't alive in 1985, so I'm not super sure how that works.
Well, other years we can go early mid 90s. Choose your year. 30 plus years ago, let's say, kind of dawn of the internet.
Yeah, we can go with dawn of the internet. I would say perhaps the core approach to innovation would still have been the same. Mission Zero was born 30 years ago when the internet came about, but definitely the speed at which we have since iterated and optimized and learned about our technology would have been far more sluggish. Not From two perspectives, actually. One would be simply at the rate of internal knowledge dissemination and processing that would be possible in the computational systems of that time. But secondly, also the external communication and managing of information. For example, if we had a technology partner who we met this week and we gave them the latest results and then they went away and did some calculations, we would lose valuable days trying to go and meet them again to say, we got some new results on the Friday, here's what's up, things have changed, and go and redo the work that you guys spent Monday to Wednesday doing again. And those kinds of loss of man
Mhm.
hours, which were, to my understanding, quite unavoidable back maybe 20, 30 years ago, are things that we have definitely managed to escape and bypass in the present era. So it is a nice case of brings innovation into being at the right time for it to learn quickly enough. And right now, with the advent of language learning models and AI becoming widely accessible, that is also going to be a huge nexus for all of technology development and R&D. Hopefully, not in other less palatable ways as well, but we don't know about
Yeah. Yes, that's a much bigger a much bigger debate about where that's going to go. Um, as we wrap up, I always love to kind of finish on the kind of optimistic or what people are really excited for in the future. And this can be about Mission Zero or it can be about engineering more broadly. What are you excited for, Shil? What really kind of gets you G'd up about where engineering's going?
that. Probably a few different things. One thing that is particularly exciting is just how much more user friendly the tools for engineering are these days that are available to all disciplines of engineers, not just like chemical, which is my trade, or mechanical, or software, even. Uh, all trades of engineering now have really good tools that are easy to grasp, at least start with, and comprehend and share and communicate information via. These are things that were really necessary because no matter how brilliant someone is as an engineer, if they can't communicate their analysis or their outputs or things to people effectively, that's a bottleneck in the process. And so having all of those things much designed way better for what they need to do for not just the user, but the other people involved is great. The other great things about engineering is just the new ways in which other newer hardware technology development companies are taking on the philosophy of engineering itself. So the way we talked about how we're doing direct air capture technology development, I like to think is a pretty exciting way to do it. But also in other
Mm.
sectors, for example, the newer companies that are developing space technology, right? The approach they're taking is radically different to what the institutional space agencies of the past used to do. And as a result, there's a lot of things that they're able to do which no one thought was going to be viable, simply because they chose to do something a different way. It's not that someone invented a new material and that unlocked something else. It's the way of thinking and approaching engineering that has shifted a lot more, at least in the media. And I hope that all of these will be successful. They come with their own risks, but as long as we keep that in mind and innovate responsibly in this new paradigm of engineering globally, then I think we're in for great things. And Mission Zero is keen to be a part of that.
Yeah. Well, I'm really looking forward to seeing where Mission Zero goes, and when can I expect to see one of these out in the wild, Shill, or is that a closely guarded secret?
It's not that closely guarded. I would say before or just after Christmas is quite likely, depending on how the Santa's
Oh,
feeling.
wow.
In the UK, you'll see something about.
Okay. Oh, what a great tease to finish on. Thank you so much, Shil Ghosh, for joining us on Beyond Blueprints. Really looking forward to seeing the future of DAC technology, and yeah, really inspiring to have you on today. So thanks so much for joining us on Beyond
No,
Blueprints.
really grateful to be here. Thank you so much, Andrew, for having me, and looking forward to the future episodes as well.
Cheers. Thanks
Thank
very
you.
much.